The next topic we're going to talk about is motion graphs, and what we're going to do here is lay down some of the basic principles about motion graphs. For each one, we're going to talk about these three questions here. How do we get information about the position, the velocity, and the acceleration? And then we're going to go a little bit more in depth on what that actually looks like. So we'll just start real basic with those three questions. So to answer that first question, how do we get information about the position? Well, it is a position versus time graph, so we simply read the graph. So if we have some line here, let's say it looks something like this, all right, and we want to know what our position is at a given time. We're just going to go to that time and look across at the value on the y-axis. We see the y-axis represents the position in meters. So we're simply going to read the graph. How do we get information about the velocity? We can sum that up in one word, and that word is slope. Everything you need to know about the velocity is contained within the slope because the slope is the velocity. Whether it's positive or negative depends on if it's a positive or negative slope. If the slope's increasing or decreasing, that tells us the velocity is increasing or decreasing. Everything that we need to know about velocity we can get from the slope of the graph. And the last thing, and this is the one that's probably the most unfamiliar to you, but we're going to talk a little bit more about this, but the way we get information about the acceleration is we're going to look at the curvature of the graph. So on its most basic level, if a graph is curved, a position versus time graph that is, that indicates an acceleration. So something like this would mean that our object is accelerating. Right? We can get a little bit more specific. We'll talk about that in 1 second on the next slide. All right, so we're going to elaborate a little bit on that last slide and look at a few more specific cases, but it does all go back to those concepts that we just talked about. So the first question we want to elaborate on is how do we tell the difference between a positive and a negative velocity? We know that slope is the velocity, so all we're going to do is we're simply going to look at whether or not we have a positive slope or a negative slope, and that's going to tell us if our velocity is positive or negative. How do we know if we have a positive or a negative acceleration? We talked about that as being the curvature, and I know this is maybe a little bit more of a foreign concept to you. If you're in calc this year, you'll talk a little bit more about this. But what we're really looking for is it concave up or concave down? So let's talk about that for a minute. Concave up is a graph that looks like that or looks somewhat like that. It could only be just maybe part of it, not necessarily the entire U, maybe just that part or just that part. But concave up, you can always remember up like a cup, that is a positive concavity. And if our graph is like that, it will have a positive acceleration because that curvature tells us about the acceleration. If it's concave down, something like this, okay, we can remember the saying down like a frown. All right, and that would be a negative concavity. So if our graph looks like this U or part of it, maybe just that part or just that part, we're going to have a negative concavity and therefore a negative acceleration. By the way, I have to give credit to Miss Papo for the up like a cup, down like a frown. She's the one that came up with that. Lastly, if there is no curvature, which would be just a line, that would be an acceleration of 0. The last question we're going to ask ourselves is how do we tell if we're speeding up or slowing down? There's two ways. We could look at the answers to these two questions, right? Because if we know the sign of both the velocity and the acceleration, we can easily figure out if we're speeding up or slowing down. But there is another way of looking at it. And what we're looking at there, if we want to not worry about finding the sign of our velocity and our acceleration first, is we're going to look at whether or not our graph is becoming more sloped or less sloped, aka slopier or flatter. So we know that the slope is the velocity. So if we have a situation where our slope is looking like that, or maybe it's going down and becoming more slopier that way, those are both cases where we are increasing the value of our slope and therefore we are speeding up. On the other hand, if we have a situation where it was going down, so maybe we started out steeper and we flattened off, or we were going down steeper and then flattened off. That's a case where our velocity is going from greater, because there's a greater slope, to less. So that would be a case of slowing down. Moving on to velocity, same basic three questions. How do we get just basic information about position, velocity, and acceleration? So, moving on to a velocity graph, the only thing we can actually get about the position is the change in position. And so we're going to hold off on talking about this until we do a mathematical piece to this. But for now, just know that the only thing you can get about the position is the change in position. How is it changing? Is it becoming bigger or is it becoming smaller? Moving on to the velocity. So this is a velocity versus time graph. We see that on the y-axis there. So how do we get information about the velocity? We simply read the y-axis. Just like we did with the position graph, we read the axis to get information about the position. With the velocity graph, we're going to read the graph to get information about the velocity. And then, how do we get information about the acceleration? We're just looking at the slope. Moving on to some more specific questions, we'll start once again with how do we know if there's a positive or negative velocity? We're simply reading the axis, so if this is our graph here. If we're up here above the axis, that's positive land, and we have a positive velocity. If we're down here below the x-axis, that's negative land, and we have a negative velocity. Positive or negative acceleration? Well, now acceleration is slope, so in order to determine a positive or negative acceleration, we're simply looking at do we have a positive slope or do we have a negative slope, because slope is the acceleration. And lastly, that speeding up, slowing down piece. How are we going to determine that here? Once again, knowing the sign of both your velocity and your acceleration using these methods would allow you to do this. But there is a way of doing it by just directly looking at the graph. And what we're looking at there is whether or not we're going towards the x-axis or away from the x-axis. So if we have a graph where our line is going away from the axis, so maybe our line is either like this or like this, that's going to be a case of speeding up, because we see here our speed, right, the y value is smaller here than it is here. We're traveling faster, so this is showing speeding up. And same thing in the negative direction. Here we have a value close to 0. It's negative, so the opposite direction, but still close to 0. And as we go along this line, we get further and further away from 0, which means we're going faster and faster. Slowing down, on the other hand, would be going towards the x-axis. So our graph could either look like this, going from a bigger velocity to a smaller one, closer to 0, or our graph could look like this, going once again from a bigger velocity, negative but still bigger, to a smaller one. Okay, lastly, we have acceleration versus time graphs. And we're not going to go into depth too much about this. You may every once in a while see an acceleration versus time graph, but it's going to be few and far between, because we mainly are going to deal with constant accelerations. So that means there's really only three possible graphs. We either have constant positive, which would look like that, constant negative acceleration, which would look like that, or zero acceleration, which would just be riding that axis. So really we're going to focus more on the sign of the acceleration, but not as much of the actual graph, because quite frankly they're boring here. It's just three horizontal lines. Okay, we're not in this class really going to deal with, mathematically at least, a changing acceleration. We might talk about it conceptually briefly, but not mathematically.